I will explain first the node protection, okay? With the node protection, you are protecting actually the node failure. But what you said is, I think, head end to tail end, we are trying to protect. It's not correct. If we are trying to protect end-to-end path, we call it path protection. Node protection and link protection is local protection mechanisms, and it's also called FRR, fast reroute, because local protection. If you are doing path protection, the failure needs to be signaled up to the head end, which can take longer than even 50 milliseconds based on propagation delay and other things. Your specific question, how this next hop is sending the required label to the PLR, point of local repair in the MPLS TE term. How it's done? Basically, it's done with the session attribute in the reservation message. We have two messages in the RSVP TE, pet message and reservation message, as you know. And in the reservation message, there is lots of attributes. And one is called session attributes. Expected label by the next hop is signal to the PLR. That's how it's done. Otherwise, if the next hop fails, next hop wouldn't receive the expected label. Normally, it would expect label from the next hop, but next hop fails. That's why next hop should receive now from the PLR, point of local repair, which is directly connected to the failed node, will send basically through the protection LSP to the next hop. There are two mechanisms for the local protection in MPLS traffic engineering fast reroute: link protection and node protection. Okay, these two protection mechanisms basically can give MPLS enabled network by enabling also RSVP traffic engineering, can give these networks 50 millisecond failover time, failover to the backup LSP. We were talking about node protection in case router fails, okay? Not the link, but router fails, then we call it node protection. This was the question. Do you guys have other question, by the way?